Hello and welcome to lecture number 5. You just watched lecture number 4 at home, as you are all very motivated and good students, I suppose. And I expect nothing less from you. So today we actually had a plan of having an invited lecture. There was a short notice change, and unfortunately you have to live with me now. But Annie will be back next week for the Circular Societies, so please use that chance to be here in large numbers to enjoy that session. And I already told the offline audience essentially that the students before you in the last semester were way more motivated. Sorry, I have to make a short break because Chintan is replicating that audio here in the room. They were much more motivated when it came to actual attendance here. So last year we had at least like 10, 12 people in this room at all times and not just online. Of course, if you live in Göttingen, that might be a different story, but please come and make this here a nice experience. Anyway, so talking too much, circular economy today. So in the lecture 4 that you watched at home and online, the topic was essentially the limits to growth. So you got an idea where parts of this name for this lecture came from. In particular, based on this book, as well as the World 3 model that was like one of the major aspects of that book, which on a very high level, on a global level, looked at various aspects like population, resource consumption, environmental pollution, and so on. So different factors, how they play together in like normal scenarios, but also in scenarios where you assume, for example, unlimited resources or unpredictable and unforeseen technological advances that people attribute often, or like where they hope that this is essentially going to save us, that sure, stuff looks really bad now, but if we just have more resources, or technology is going to save us, technology is going to be our Jesus, and if we just push technology hard enough, this will somehow make sure that we do not really have to change our behavior and everything will be fine. And based on those World 3 model simulations, you could see, okay, it might help in a certain sense, and it might be part of the solution, but just continuing as we do, or as we're doing right now, and then hoping for technology to save us is probably not going to cut it. And of course, this is like a very simple model, even though quite powerful. It also looks at things on a global level, but yeah, some pros and cons. But I guess I think it's like quite helpful and important tool to understand some of these aspects and concepts, and especially how they relate to each other and how they influence each other. We will come to a more fine-grained look at a similar problem for specific products and services later, where we talk about life cycle assessments, because this was essentially on a global world level. And later we will also look at the, for example, specific resource consumption and environmental damage that the particular service or product is going to cause. So a little bit similar to the CO2 footprint, but way more detailed, way more complex. We'll come to that later, but due to all like the guest lectures, we couldn't put those 2 lectures just in a row, so we had to take them a little bit apart. Today, we're going to look at the circular economy, or the overarching research theme of this university, of Clausthal University of Technology, and also a potential building block to help with some of the problems that the World 3 model outlined. So we have a finite planet with finite resources, and in order to get as many resources back, or to use those resources that we have as best as we can, there are different concepts available, like recycling is going to be one of this, and it's also part of the circular economy, but there are further steps that you can take to make the most of every atom of any resource that you gathered in the first place and use it as efficiently and as long-lasting as possible. And this is why we're going to talk about the circular economy. It's not going to be the solution. Just implementing a circular economy is also not going to cut it, but it can be, and this is what large parts of this lecture series are about, it can be a useful building block towards a future worth living. So let's jump in. introduction. Coming back to the definition, just as a quick reminder so that you all know this definition by heart when I wake you up at 3 a.m. in the morning. So sustainability is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So not fucking up our world right now for short-term gratifications, but making sure that other people can also enjoy this planet. And I made the previous case that usually the most sustainable thing you can do is consume less, because that leaves you with more resources, that makes you polluting the environment less, using less energy, and so on and so on. So there are like various pros for consuming less, because usually it means less damage to our planet, less climate change or global warming, less environmental pollution, less resource scarcity. So directly linking to those 3 key challenges that we outlined in the beginning of the lecture or the lecture series. And in stark contrast to that is our current predominant economic system, which is usually referred to as either the linear economy or the linear industrial economy. I'm probably going to use linear economy because it's shorter. And that is, in very, very simple terms, a 4-step process. You have resources that you're extracting somehow from the environment. It can be mining, because we're also an old mining university. It can be harvesting timber. It can be agriculture. It can be fishing. So you're harvesting a certain resource. Then you take that resource and produce something out of this. Fish might be now a bad example, even though you can also make products out of fish. But let's say you're producing this now functional, very nice pointer, which you build based on the resources. Once you have manufactured this nice pointer that I'm using to give this presentation, you somehow first have to distribute it so that people can buy it, and then you sell it. So you take resources, you make something out of this, and then you sell it. And this is how most of our economy works at the moment. We take resources, we make something out of this, we sell it, and once it's sold, most manufacturers don't really care about it anymore because they already make their money. And everything that happens after this point of sale is not considered the problem of the seller or the original manufacturer anymore. So it doesn't really matter how difficult it is to recycle it, how difficult it is to repair it. They got their money. They have limited interest in doing anything with that product anymore. Actually, it makes more sense for them if this pointer is broken after, in Germany, not 5 minutes because you have a 2-year guarantee or warranty time, but if it fails after 2 years and 1 day, they're most happy because then I have to buy a new one. And I have to somehow figure out how do I get rid of this in the most sustainable, least environmentally damaging way. There might be some exceptions to that, especially now that we're going more towards this subscription model-based approach, especially for digital goods, that the users or that the sellers don't really sell it anymore. They're more leasing it to you or renting it to you. We'll get to that in a second as well. But the predominant part of our industry, of our economic system at the moment is taking resources, making a product out of it, selling it, and then not caring about what happens afterwards. And therefore, you can also briefly describe the linear economy as take, make, dispose. So, long version with shiny illustrations, short version, take, make, dispose. Obviously, there's also a proper definition for this one. It's as follows. The objectives of the linear industrial economy are to maintain value, not to create value added, to optimize stock management and not flows, and to increase the efficiency of using goods, not of producing the goods. So essentially, you want to produce as much stuff as you can, get rid of it, and make the most profit. So you don't want to add any extra value based on this. You just want to make the most profit by selling as much stuff as you can for as cheap as possible, like producing it as cheap as possible and then maximizing profit, sorry about that. So it's about increasing the efficiency of using goods. And when you extend the initial figure a little bit, this liability border that I in the previous slide described more intuitively as saying like after you, like this manufacturer sold the product to you, it's not their problem anymore, is now like illustrated here in a little bit more detail. So liability before the point of sale usually lies with the manufacturer or those people who like do stuff with it. But once you bought it and then you are using it, you are the person left with a problem. So at some point, everything goes to waste. You have to figure out, where do I dispose it? I have a broken TV. You have to get it to the waste dump and not just throw it into the next forest or the next river, because if you can't see it, it's not a problem anymore. Also waste management, like then extracting most of the resources out of those waste is also not the problem of the manufacturer anymore. This is one of the reasons why most products are designed in an extremely shitty way that does not really allow for easy extraction of resources. Because why should the manufacturer care? They are not liable anymore. They just buy new virgin resources that have been extracted from the environment and start all over. They are not responsible in quotation marks, for the growing piles of waste that are accumulating on our planet. They also are not, as for now, accountable for most of the environmental damage that happens either while extracting resources or during manufacturing process, but definitely also not as part of the waste management. When we talked about various challenges and disadvantages of recycling, like very energy intensive, also leaking a lot of stuff into the environment, most stuff not even making it to the recycling point, and then also the different quality levels that you get from recycled product, they are not liable anymore. And this is why this term liability border, I don't want to say it was established, but somehow came into place, because you differentiate between manufacturer's problem, not their problem anymore, but rather your problem as the end consumer and society as a whole. And we already discussed that we really suck at waste management as a society. So just throwing it into the next lake, river, ocean, or creating large piles of trash that people can try to still elicit some resources from under really fucked up conditions. But all of this, once again, not the manufacturer's problem anymore. And we also talked about this very nice example of how you best dispose your nuclear waste by throwing it into the ocean or burying it somewhere where it becomes a problem for all the generations after you, while you just profit from the nice, cheap, supposedly cheap energy. And the same is like true for a lot of the consumer products that you use in your daily life. If an iPhone would account for all the environmental damage and societal damage that it causes, it would not be 2,000 euros, it would probably be 10,000 euros. No one would probably pay 10,000 euros except for some super rich people, but you probably won't pay for it anymore. I'm not sure how many people of you pay like 2,000 euros for an iPhone, but I think the point that I'm trying to make is clear. If you have to account for all the damage that you do to society by not having this liability border that we just discussed, stuff would be way more expensive and people would be way more careful with what they buy and how they use it. Plastic was another example that we discussed extensively. We also looked into the recycling example and the limits of recycling. So those are just like really brief refreshers that I'm not gonna spend a lot of time talking about. There is a somehow interesting perception that I think I first read it in a book about production and manufacturing, I think from Japan, if I'm not mistaken, somewhere in Asia, where they had this notion or this understanding that waste is just a sign of inefficiency. And you can also usually see this very nicely in nature, where the concept of waste from natural cycles does not really exist. Like if a tree falls over, it's going to be 100% recycled, repurposed, reused by other plants, by other species, by other living things, to be very vague. There is not really a concept of waste. Whatever is created will also be somehow be utilized. And you have some kind of a circular system, and I think you're already getting a little bit where I'm going. And if you essentially take the same or translate this into an industrial setup, humans are a little bit weird in that sense that we're just fine with extracting more and more resources and then throwing them away and hoping that this can go on forever. So we do not really have the circularity in mind. And of course, like in the last few years, this has changed a little bit. Everyone has heard about recycling, even though most of you or most of the people don't really take it that seriously. And we also discussed the downsides. But there is a growing idea that we should think about keeping resources in a circular loop to not lose as many as we do right now. But this idea that waste is a sign of inefficiency and therefore should be completely eliminated, that's something that we're extremely far away from still. So what are we now trying to do? We have this linear, very inefficient, because it produces a lot of waste, stream of the linear economy that we're now trying to extend to have a more circular system. So instead of getting rid of our resources after we have used them, we're trying to keep them in a cycle for as long as possible so that we can use every atom that we once somehow obtained for as long as possible at the highest quality level of possible. And thereby them addressing the main challenges of the linear economy. So there's at one point environmental pollution and the waste that goes into the environment. It's a waste of resources, and just recycling is not really going to cut it due to all the disadvantages that we already talked about. And besides just consuming less, the obvious thing, we're going to focus on using stuff much longer. That can be services, it can be products, it can be anything, and maximize the resource utilization of every single resource that we have. And this is essentially where the circular economy comes into play as one of those potential solutions and the overarching research theme of this university. So this is actually a figure that was designed here at Digit and that I still like very much because it captures a lot of aspects of the circular economy in a very nice and easy to understand, but also easy to remember way. So we start at the top of this nice circle. We still need some resources, or let's say we already have extracted some resources that we put into a product and manufacture something. We're still going to sell it, potentially, and then use it. Besides just you using it, one of the themes that the circular economy is promoting heavily is the sharing aspects. So cars are always like this really nice example. They're mostly sitting in a parking spot for 23 hours a day and not doing too much stuff. They're even worse example, if you have a power drill or any types of tools at home, they're probably being used, I don't know, depends on how much you like to work with tools, I don't know, once a quarter, once a year. And most households have a power drill, but most of them are also not really using it. So instead of buying one for every person on this planet, makes of course way more sense to have one available for people to use it and thereby maximizing the utilization of just a single power tool instead of having hundreds or thousands of those power tools. So using as normal as you would do right now, but also sharing and thereby maximizing the utilization of a certain product or object is one of the first parts of the circular economy. At some point, you will, for whatever reason, reach the end of use for a product or a service. Maybe you just don't need a power drill anymore because you decided you're getting too old for this stuff and you don't want to fix stuff anymore, or you don't need a car anymore or whatever, or there's just something broken in there. That could also be the end of use. So then, instead of then just going to this, okay, it's time for waste management, we enter the first circle of the circular economy, which is going to be reuse and repair. So is it really at the end of use? No. Can I reuse it in a different context? So battery electric vehicle batteries are one of the examples that are very often used. even if those batteries might not have the capacity and the quality any longer to be used in a battery electric vehicle, they can still be used, for example, as a power bank at homes. So you can have a solar setup at home, you can feed that into this old car battery, and at night you can use the old car battery to power your house. So you use excess of solar power that was gathered throughout the day, and then later use this battery that has only 50% capacity left and is now powering your house. It's just like one of many examples. So trying to reuse already manufactured goods without much tinkering in a very easy and straightforward way. That's one of the ideas, instead of saying, okay, we have to now recycle this battery or throw it away. Second option, very easy, repair. If something is broken and I can easily repair it, why not? Of course, this has like the precondition of being repairable in the first place. A lot of products are designed in a way that does not allow for easy repair. So there is also at the beginning in the manufacturing process the idea of making things or redesigning things in such a way that they are easy to repair, even though that might not be in the best interest of the manufacturers. But repairing things, of course, is one of the most straightforward things to prevent this end of use and just bringing them back into the first cycle. So first cycle, reuse, repair. But let's say there's no reuse and no repair option for the product that we're talking about. So it really has reached its end of use, but did it reach its end of life? Because there are some options to prevent this end of life for a product. Namely, for example, refurbishing, which essentially is a little bit more nicer way of repair. So either like trying to replace certain components or to, so like for example, you can often like buy, for example, refurbished vacuum cleaners online for cheaper. So like you can buy the new one, or you get a refurbished one that was like has some scratches, or where certain components have been replaced, or where we took 3 broken vacuum cleaners and made one functional vacuum cleaner out of those. Like there are different examples. You can also go down the line of remanufacturing a certain product. There is like quite a little bit of overlap between those things, but the idea essentially being, okay, it's not easy to repair, but there's still a value to this product that has reached its end of use, but not the end of life. I can still do something with this existing thing that I've already created using substantial amounts of resources. And only if that cycle has also concluded and we really have reached the end of life for something, then we go to recycle and recover. So most people have this intuition that they're already doing something really good and really sustainable if they have something and then put it in the right trash bin to be recycled. But this is more or less the last resort, the last option in the context of the circular economy. So first we try to reuse and repair, then refurbish and remanufacture. And even before that, like using and sharing and maximizing utilization of certain products, like all of this comes before I even think about recycling and recovering. In best case, it takes ages and only a minimal part of all of our resources even go back to that stage of recycle and recover. We'll talk about various aspects of this in more detail, but I think this figure very nicely explains this general idea. So instead of having a linear economy, we're trying to keep everything in the circle for as long as possible and use everything to the maximum amount of, or to up to the maximum limit of its abilities. And of course, we'll also provide you a definition of the circular economy, which is as often not as straightforward as it sounds in the first place. So there is this one paper from 2017, so 8 years ago, where they already found 114 definitions of the circular economy. I assume that now in 2025, or at the end of 2025, we're probably talking about even more definitions of the circular economy. We're going to use, or we're just going to introduce a few ones, and you can pick which one resonates the most with you. There's obviously like a heavy overlap between those different definitions, and they focus on particular aspects that they deem to be more important than others. But all of those that we're presenting here are essentially fine. I have my favorite one, but you don't have to pick this one. So let's first look at the circular economy definition of the Ellen MacArthur Foundation, very circular economy focused foundation. The circular economy is an industrial system that is restorative or generative by intention and design. That's the first aspect. It replaces the end-of-life concept with restoration, shift towards the use of renewable energies, eliminates the use of toxic chemicals which impair reuse, and aims for the elimination of waste through the superior design of materials, products, systems, and within this business models. So if you think back at the figure that I just showed you, there is a lot of overlap with this, even though extending that a little bit. So not having an end of life for things, but rather trying to use them as long as possible. Using mostly renewable energies to do something, trying to avoid toxic chemicals that somehow have an environmental impact, trying to have this idea of reuse by better designing products and services or materials, and also thinking about, okay, if we want to do this, what business models are compatible with this new economic system? Because if it was thus far, I get resources, I make something out of this and I sell it, and then I don't care about anything that happens with this product anymore because I got my money. Like, if this is not an option anymore, then you also have to rethink how your business model potentially works, because you're still in an economy, the circular economy. Alternative definition by the European Parliament, a little bit shorter. The circular economy is a model of production and consumption which involves sharing, leasing, reusing, repairing, refurbishing, and recycling existing materials and products as long as possible. In this way, the life cycle of products is extended. So once again, you can see some similarities with the previous definition, also with the figure that I already showed you. Here it's specifically about certain things, certain activities, certain suggestions that you can do to achieve this goal of using resources or products for as long as possible. Not really a focus on renewable energies or avoiding environmental pollution explicitly, more like implicitly by, if I use every resource for as long as possible, then I potentially, implicitly damage the environment less, but it's not like a core focus of this as in the previous definition of the Ellen MacArthur Foundation. Now, from my favorite, but you don't have to choose this as your favorite, I just find this like the most concise one. It's coming from this book that a lot of the slides for this lecture are based on, from Walter Stahel, The Circular Economy, a User's Guide. And Stahel defines the circular economy as follows. The circular industrial economy manages stocks of manufactured assets, such as infrastructure, buildings, vehicles, equipment, and consumer goods, to maintain their value and utility as high as possible for as long as possible, and stocks of resources at their highest purity and value. So the first thing that might come to mind, or that might be like going beyond what you've seen thus far, is that we're not just talking about products and services here, but also more implicitly, for example, about infrastructure and buildings in particular, which are often not really seen as consumer goods, but they're also like a large chunk of the economy where a lot of resources are used and where a lot of environmental pollution is caused. So even infrastructure and buildings are resources for the future, in best case. So manage those existing things that you have manufactured as best as possible. By, for example, maintaining their value, like what are they worth, but also their utility. What do they provide us? What problems do they solve for as long as possible? And the resources within that at their highest priority and value. So I'm not just wanting a product that lasts for as long as possible, but also making sure that if I put 5 atoms of copper in there, that I can also get those 5 atoms of copper out in the end, and that they are at best indistinguishable from 5 atoms of copper that I just harvested or extracted from a copper mine. So managing the stocks, maintaining their value and utility for as long as possible, and also keeping resources at their highest purity and value for as long as possible. And that fits, from my perspective, very nicely in this definition of the sustainability, with you meeting our needs without compromising the needs of the future generations. So let's look at some characteristics of the circular economy and also trying to put it a little bit into the context of the linear economy and the circular economy, like how do they relate to each other. So we still have this process at the beginning where we extract virgin resources, because at some point resources have to come from somewhere, but we've already extracted a lot. There are a lot of resources in circulation, and there's a shrinking amount of resources that we have not, or that we can still extract. So you still extract something and you still make something. But after the point of sale, or already as part of the point of sale, we have the circularity idea for circular societies. We'll talk about that next lecture. But primarily from the circular economy, where we then try to use those objects that we have produced for as long as possible, getting the resources at the highest quality and value out of this, and essentially trying to substitute as much as possible, at best 100% of the resources that go back into manufacturing. So essentially the idea of 100% recycling quotas. Like whatever I extracted, whatever I used and put into a product, at some point I want all of them back. Not just, what was it, 10%, 9% in plastic, and 90 or 95% virgin materials, I want all of them back. So essentially the reverse. And within the circular economy, there are 2 so-called eras. First, the era of R, and then later, the era of D. And the era of R usually starts with the letter R to make it a little bit easier to remember what are practices and things that are done in the era of R to fulfill this definition or this goals of the circular economy. So I have the era of D mostly focusing on the atom level, and the era of R mostly focusing on maintaining value, quality, and quantity of stocks that we have. How can I do this? For example, by reuse, repair, remarket, remanufacture, re-refine, reprogram. There are a few more depending on which book you read or which literature you consult. But you're not just supposed to learn those by heart, but more to get an idea what are different things that I can do to keep that one product or thing that I have for as long as possible, so that it provides the maximum utility, so the maximum problem-solving capacity for society. So reuse, pretty self-explaining. Repair, also remarket, like I have a smartphone that I don't need anymore. Instead of throwing it away and giving it to recycling, I can resell it or just give it away to someone so that they can use it. Remanufacture, like rebuilding a product, re-refine, reprogram. For example, computer chips, sure, they've been made for purpose A. I can still repurpose and reprogram them for purpose B. Especially for control units, that's usually quite simple because they're super stupid multi-purpose computers. Like they don't really care if they are counting beans or apples or if they are now controlling the temperature of my greenhouse. So there are like different approaches, and this list is by no means complete, but it's supposed to give you an idea, okay, what are things that I can do to maintain value, quantity, quality of stocks that we already have. Let's say we've done this to the absolute maximum. Now it's really time to get resources back. This is then essentially when we come to the era of D, which focuses on technologies and actions to recover atoms and molecules at highest quality, meaning essentially purity and value, at the same level as pure or virgin materials. So those are then mostly going into the direction of material science, chemistry, whatever. This is really not my field of expertise. So I have polymers, so I try to depolymerize them. I try to de-alloy things, to delaminate, to devulcanize, to decode, to deconstruct, which makes most sense like for buildings and major infrastructure. So essentially everything I can do to get those 5 atoms of copper that I put in something back in the same quality as I put them in. And thus far, most of those recycling methods have a certain loss function, that if I put 5 in, even if done perfectly, I get maybe 4 back or so at best. There are some products where I can get 100% back using a lot of energy. For example, like aluminum is really nicely recoverable and recyclable. Glass also to a certain extent, but as we discussed with plastic, usually combined with a quality decline and also various losses on the way. But this is the main idea. So error of R, maintaining value, quality, and quantity. Error of D, trying to get my atoms that I put in back and at the same quality as virgin atoms that I just mined or extracted from somewhere. Important aspect also in the circular economy is this idea or is this concept of the end of life. But we're not just saying, okay, it's end of life recycling, because we already discussed this is essentially just the last resort. Therefore, we're looking at the end of life in a more differentiated way, which means more brain power to be used, but also more to be gained. Because usually I'm trying to use the high value route for something that has reached its end of life or end of use for some, for one user, for example. So I'm always trying to first go the high value route. So I don't use this anymore. Maybe someone else can use it, reuse it. It's a little bit broken. Okay, I cannot give it directly to someone else to reuse it, but we repair it, then bring it back into the cycle. If repair doesn't work anymore, maybe remanufacturing works. Upgrading and so on and so on, like this list in between is definitely not complete, but you get the idea of I first try to do the thing that remains or it keeps the highest value, the highest utility with the least amount of input and effort. And only if all those options above fail, then I go to recycling and then essentially the error of D. So I always prefer the error of R over the error of D, because recycling and all this other stuff super complicated. I have losses and so on and so on. So whenever I can keep something at the highest possible value, I will always try to do that in favor of anything at the lower route. And that also leads to important distinctions which then have in influence, or how do you best say that, essentially implications for business models and the working of that economy. And bear with me and maybe watch this video 2 or 3 times, because when I first looked at this figure from the book, I also was rather confused and it took me a little bit, but I'm trying to explain it as best as I can. And if there are still questions in the Q&A, I'm happy to explain it from different angles again and again, but let's try for now. So let's first look at the linear economy. The linear economy is characterized by a low hour to kilogram ratio. So I'm trying to produce with as little effort as much as I can. So a lot of optimization to produce a lot of stuff. The more stuff I produce, the more money I can potentially make. So low hours in, maximum kilograms out, which is essentially coherent with mass production and highly mechanized and automated processes. It also has a low to medium euro to kilogram ratio. So value per weight. What I'm producing a lot of weight, but usually that weight that I'm producing does not have a high value. So this could be something like cement, smart goods like USB memory sticks, so everything that essentially you can mass produce. Like this is one of the characteristics of the linear economy. For the cheapest possible price, I try to produce as much shit as possible that I can sell then for a profit. This is like why we have Temu, Alibaba, in a certain sense also Amazon, producing as much shit as possible, selling it to people, make a dime. That is not really compatible with the circular economy, as we just discussed, that I'm trying to produce the cheapest stuff that barely makes it over the warranty time. So the circular economy, on the other hand, is characterized by higher hours per kilogram ratios, because if I want to reuse things, if I have to repair things to maintain their value, that usually means I have to put in more hours per kilogram of thing that I'm producing, maintaining, whatever. It just takes more time to repair something than clicking on buy again on Amazon. This is why most people also do it, besides the point that Amazon, Apple, and Co. make it extremely expensive for you to repair something extremely simple, thereby incentivizing you to just buy a fresh new iPhone instead of just repairing your broken screen or your broken charging port. So high hours per kilogram ratio. I'm putting a lot of effort into every kilogram that I'm producing. So if you looking at this figure, then the idea is that I'm somehow trying to bring those three aspects, output or kilogram use or output, money and time input or output into this equation. And I think it gets a little bit easier if you look at those two slides in conjunction, because here is, in my opinion, a quite nice additional help for understanding this concept. So we have a nice two-dimensional graph. On the x-axis, we have the value, euros per resources used. On the left-hand side, we have low. On the right-hand side, we have high. In between, we have some random numbers, 1, 100, and 1 million, whatever they mean. And on the y-axis, we have the working hours per resources used as an input, from also ranging from low to high with 1 to 10 in between. So if I have something that has a low value per resources used and low working hours input, going back here, then I'm in the linear economy, so low hour to kilogram ratio, which then basically gives me so-called Stone Age goods, but also industrial goods and smart goods that I can mass produce. So mass production and everything you can buy on Temu and whatever. So linear industrial economy activities have this low hours to kilogram and low euros per kilogram ratio that is consistent with mass production. If I'm now thinking about something like reuse, remanufacture, those are things where I'm putting a lot of hours in there, but also producing something that has a quite high and maintains a quite high value. And this example here is like what that helped me most to understand this slide and the one before best. If you look at the example of a car engine, like not a battery electric one, but a combustion engine one, comparing it to what does it cost me, or like what is the hour kilogram ratio as well as the euro kilogram ratio to produce a new one versus maintaining or remanufacturing an existing one. And it takes about 270 times as much time to do that, to maintaining it, to remanufacturing it, than just buying a new one or building a new one, manufacturing a new one. Obviously, that is much easier. However, it comes with all the downsides and disadvantages of the linear industrial economy. When I will try to keep that car engine in the circle for as long as possible, at the highest quality, at the highest utilization as possible, that will take extra amounts of work. And this is also something where you can already see alternative economic models and also future job opportunities and job markets for people that will lose their jobs as part of the migration away from mass production. Right now, a lot of people making their living either on a very shitty basis or somehow comfortable if you work for Volkswagen, sitting on production lines, mass producing products. What happens if those do not exist anymore because we have to move away from mass production with a linear economy because it's destroying our planet? Then you have to find new ways to keep people busy. If you don't completely revamp the economic system, but let's keep that aside for now. So moving towards jobs that are concerned with maintaining existing products and services at the highest quality, at the highest level, at the highest quantity, then you also need a lot of more work time being put into doing that. So jobs that are now like very scarce, like how many repair shops do you know that only do repair for a living? Sure, I mean, something like iFixit comes to mind from the electronic consumer market, but they're also making a lot of money just selling the equipment that you need. There might be your bike repair shop, but they also make money by selling new bikes. There's like very little exclusive repair focused shops because nowadays most people just throw away their old stuff, buy something new instead of going to repair business. Repair takes time, which is okay, especially if you have to find ways to keep other people who have previously worked in mass production somehow in the job market and providing them alternatives to mass production jobs. So there is an opportunity. It's not just like, oh, if we get rid of mass production, everyone will be poor and suffering and dying because there's no food left. No, there is actually more work to be done. It's more work to be sustainable. This is unfortunately usually the case. If you're trying to be more sustainable, it means more effort, more work. Because right now, being unsustainable usually only works because you're offloading all the time, all the effort, all the damage to the society and saying, yeah, it's not my problem. We crossed this liability border, it's not my problem anymore. But if you are fully responsible for being sustainable, that just takes more time. So, long story short, linear economy, low hours per kilogram and low euro to kilogram ratio. Circular economy, a lot of hours input to maintaining high value. And if you keep this example with the car machine in mind, this is probably the thing that best helps you to understand this. If I want to maintain the high value of a thing, it takes way more effort and way more time to just buy something new or produce something new. There are some aspects that Anni now could probably explain much better than I or circular economy business people, because I'm just not the business people despite having had a few companies in the past, but not my field of expertise. But there are some like business model characteristics that we can briefly touch because we'll also get to the so-called performance economy in a second. One characteristic, for example, from the construction world, when it's about building infrastructure or buildings itself, that you try to use renewable raw materials instead of materials that are finite. So of course you can build something like a house that is made of a lot of plastic and other stuff for insulation or whatever, or you can go for insulation made out of regrowing resources like woody stuff. So you can get, I only know the German words, unfortunately, but of course there's like insulation made out of some kind of petroleum-based systems or chemical stuffs or something that you essentially have to manufacture from resources, or you can just take so-called Holzfaserplatten, which is essentially just woody stuff that you somehow press together and then also insulate your house very well. At the moment it's more expensive, as always with the more sustainable stuff, but you can do it. So you can try to use renewable raw materials that at the end then are also like easier to reuse, recycle, or bring back into the cycle than those that you can just put on a waste dump. You can also think about business models that help to intensify the utilization of existing products. So we talked about the sharing of a power tool, of a car, of whatever. So making sure that an already existing product is used as much as possible and not idling around. And then also deceleration, like you're trying to extend the product's usage period by making it easy to repair, easy to remanufacture, or just being able to reuse it, very simple. So those are just like 3 sample characteristics of the business models. Sorry, I'm not quite fit at the moment. That are part or could be part of these new business models for a circular economy. There are a few more design strategies that go hand in hand with those, but this is more like a self-study slide, and more like for background information. Now we come to a special flavor of the circular economy, the so-called performance economy. In the performance economy, I'm turning this idea of selling stuff and then getting rid of it a little bit upside down, beyond the circularity ideas, by questioning this need to sell something in the first place. In the performance economy, I'm not interested in buying or owning a product anymore. I'm interested in buying a performance that solves a problem for me. Usually, and this is like the example that I'm often using, but this is quite common in the literature, I'm buying a power tool, a drill, because I need to drill a hole to then put a nice picture on the wall. However, I'm not buying the drill because I'm interested in drills. I don't want to own a drill. I'm interested in a hole in the wall. Why can I not just buy holes in walls? I need 4 holes and not a power drill. This is what I'm interested in. I also don't want to own a car. I want to have the performance, the utility of being transported from A to B. I need a car at the moment to do so, but I don't want a car. And this is essentially where the performance economy comes into place. So instead of having this business model of selling products, which people then use, the idea is that industry players or businesses sell you performances. They essentially retain the ownership of a product and just provide you the service of this product. It's essentially one attempt, one strategy to maximize the utilization of products. Instead of selling all of your power drills, I'm having one power drill and you're just buying holes in walls from me. That means one power drill can be utilized by, at the moment, 4 people in this room and hopefully 20 more online. So that's the main idea. And it has, do I get there? Yeah, maybe I'm talking a little bit more here. And it has also like other interesting advantages, because if the manufacturer or those business entities do not transfer the ownership to the buyer anymore, they also suddenly have a very different interest when it comes to designing those products to last as long as possible. Because the longer this one drill that I produced lasts, the more holes it drills, the more money I make. They also suddenly have an interest in making it as repairable as possible, because they keep owning it. If it's easy to repair, I can get more drilled holes out of this one power drill. And so on and so on. The same goes for a car or whatever. And if then the battery of that power drill might not have the desired runtime anymore as it has before, maybe they're designed in such a way that they can then be repurposed for some other use cases. So there is suddenly a completely different dynamic and a completely different incentive system. Thus far in the linear economy, manufacturers produced something, sold it to you, and then did not care anymore. In the performance economy, as a special subflavor of the circular economy, they are suddenly interested in making a product that lasts as long as possible, that is utilized as much as possible, that is easy to repair, easy to be reused. And even if you put this to the extreme, they might actually be also interested in making it as easy as possible to get all the resources back out of this product that they manufactured, because at some point they might need to produce another new drill, either because there's a surge in demand for holes in walls, or just because this one drill that they had really reached its end of life, there's nothing we can do anymore for this drill. Then they need another drill, and in best case, they give it to a recycling company and they get all the atoms that they put in the initial power drill back in their virgin form and then just produce a new power drill. So this is essentially like this vision of a performance economy, that we, by restructuring this approach of not selling products anymore, but rather services, and thereby incentivizing manufacturers to completely take ownership and liability of products, which in the past they tried to push either to the end consumers or to the society as a whole. So, or like a very visionary concept, but there are also like parts of this in a very simplified and early stage manner that you can already see nowadays. So car sharing, for example, goes in this direction. Sure, car sharing not often operated by those people who actually manufactured the car, but also sometimes a little bit, but it's like going in this direction. Tesla, for example, was leasing their cars for a while themselves, not quite sure if they still do it, but they were essentially producing their cars, leasing them to people, letting them use it, and then essentially took the cars back and could do whatever they wanted with the cars afterwards, like leasing it to the next people or actually selling it. But there are like some examples where this already starts to happen. You can also rent some tools from some manufacturers straight away who also produce them, but it's a very, very early stage thing. You can also see a little bit of similarities with that with product as a service or software as a service things where you're not really buying your music anymore, but you're rather like leasing it, renting it. It has some overlaps with the performance economy idea, but with like a different, slightly more profit-oriented vision in mind. So you're not interested in owning CDs anymore or DVDs, like if you go for Netflix or whatever, you're interested in watching and consuming that video. So you're just paying for the performance of seeing that video. You're paying for the performance of listening to that song. Not with all the advantages and the backstory of the performance economy in mind, but some aspects of this performance economy can be experienced and observed in real life. So now I talked a lot in terms of examples, trying to visualize what this performance economy as a special flavor or a special type or a special subsection in the circular economy is. But we'll move to the actual definition in a second. I would just like to highlight one further and final extreme of this performance economy idea, which is essentially the lower part with the two green boxes here. You can actually push it to that extreme that you're talking about renting a molecule. So you're not like you're not just buying material, then using it somehow and giving it back. You can actually think about it, okay, I have this one molecule that I have to maintain at this highest value. I give it to a manufacturer, does something with it, uses it as part of a performance economy, or I just see my business model as providing those molecules to provide a service. Of course, like this is a super extreme example, but it does not have to be the performance of a product or a service. You can even like sell or lease or rent the performance of a molecule. But this is like a little bit extreme and besides the point, but just wanted to like, because usually that sticks to the brain of people. Good. Now, finally, proper definition, once again by Stahel from his book. The performance economy sells results instead of objects. Its economic actors may be manufacturers of durable objects or fleet managers operating them. In both cases, they sell the use of these objects as a service over the longest possible period of time and maximize their profits by exploiting both efficiency and sufficiency solutions. So very, very, very different to the linear industrial economy definitions where we're trying to produce as much shit as possible for as little as possible while then selling it for the highest possible price and then not caring about what happens afterwards anymore. So now if this performance economy is so great, why do we not have it? And is it really the most sustainable thing that we could ever do? Stahl has a few arguments. We'll also in later lectures look more into the direction of criticism beyond a few criticism points that I have now. But let's first hear what Stahl has to say. The performance economy of selling goods and molecules as a service function guarantees or results and performance is the most sustainable business model of the circular industrial economy, because by internalizing the cost of product liability, of risk and waste, it offers manufacturers a strong financial incentive to prevent losses and waste. This is a way more concise way of saying what I discussed when we looked at the slide before. If the manufacturers suddenly have a high incentive because they do not give up ownership of a molecule, of a product or a service or whatever anymore, they suddenly have an extremely high incentive to act very, very sustainable, because that maximizes their profit and minimizes their costs. It maximizes the profit potential by exploiting sufficiency, efficiency, and system solutions, which essentially means I'm not overselling you all drills anymore and making money based on the fact that you all have a drill, but I'm rather trying to sell you as many holes as possible, which also might end up in a weird state that you're suddenly being offered a shitload of holes instead of power drills. But this is like different discussion, because there's probably an upper limit of holes in your walls that you need and can and want to consume. Therefore, sufficiency perspective, way more, it's easier to reach a sufficient amount of holes than it might be to achieve a sufficient amount of power drills, is the point. In addition, by maintaining the ownership of objects and embodied resources, it creates long-term corporate and national resource security at low cost. If I'm not having a need for virgin materials because I'm like super picky and very, very meticulous about maintaining the atoms and molecules that I have, the less virgin materials and new stuff do I need, the less dependent I am on someone who has to provide me those virgin materials. Good. Last attempt of putting all of this together. So let's first start with this big circle, which is the circular industrial economy, managing the utilization or use of stocks of manufactured objects and their components by maintaining the value and quality of infrastructure, buildings, investment goods, equipment, and durable consumers in a local or regional economy. So this big part here, like we have the normal linear industrial part here, which produces stuff, but then we have the circular economy essentially covering the era of R, parts of the era of D, and also something that we have not really talked about yet is this focus on regionalized and local aspects. Because circular economies, especially repair, reuse, remanufacture might also work somewhere else, but maximizing the use of something, sharing is one way to do that. Repair and reuse often works best in a local and regional way. It's nice if I could borrow the power drill from my parents in Rostock, but it's, I don't know, 300, 400 kilometers to get it and then bring it back. So sharing economy, utilizing something that already exists to the maximum, car sharing or whatever, works best in a local way. Same with repair. Sure, like you can send your phone for repair somewhere that works maybe a little bit better than using the sharing example, but it also is way more convenient if you bring your phone to the next repair shop on the local level. Repair, sending away works with small stuff, but if you want to repair your bike, you're not going to send it to Austria to be repaired there. If your car is broken, you're not going to put it in a DHL package and sending it to, I don't know who's good at repairing cars, someone in East Europe, to be very stereotypical and racist, maybe, I don't know. You get my point. So for small stuff, sure, you can ship it and do it, but on a general level, local and regionally, the circular economy plays out their gains the best way. So this is the big circle. Small square is a local use focused performance economy, because also performance economy often plays out their advantages best in the local or regionalized ways. It's nice if someone from Canada offers me to drill holes in my walls, but it's probably not really a practical thing to buy holes in my wall from Canada. It works best if the person who can drill that hole works in a very close proximity to me. The same goes for this like transportation, this example of, I don't know, an autonomous self-driving cars offers to drive me from A to B for $5. That also works best in a regional and local level. And various other examples would follow suit. So circular economy best in a regional and local, performance economy usually best on a local level. And then the big square is essentially the flows of used materials returning to the raw material producers to recover molecules and atoms in a globalized economy. So part of the linear industrial economy, but also the bigger one. Good. I know that was probably quite a lot. So we'll save us the criticism of the circular economy because it's like promises a lot of solutions. It can also make substantial contributions, but yet it is not perfect. But in order to save your brains from overload, we'll keep it for that. So we looked at the linear economy, or maybe I can just use the actual conclusion, which you can easily summarize as take, make, dispose. The circular economy, which then tries, in contrast, to maintain value and utility as high as possible for as long as possible. And we also looked at this weird subcase, the performance economy, which sells you results instead of objects. Maybe sleep a night or 2 nights before you may have another look at this hour to kilogram ratio figure that is a little bit unintuitive in the first place, but have another look at it, check if it still makes sense. If not, then please let me know. Usually trying to explain it as best as I can, but it is a little bit unintuitive in the first place. And yeah, do we have an exercise for this week? Okay, we do not have an exercise for this week, so I do not have to put a reminder for an exercise in this video. There are a few more additional resources, namely the book from Clausthal that we used to create parts of these lecture slides. The L MacArthur Foundation also has an interesting website with additional resources. Once again, of course, not a complete list, but especially the book from Clausthal is a quite nice dive into the circular economy. If you, on one hand, want to read up on some of the things that I might have explained in not quite optimal ways, because Clausthal might be able to explain it better, or also if you want to get a little bit more input on what we discussed here. So next lecture, the circular society as a complementary thing to the circular economies, not as an extension, but more like covering parts that the circular economy completely ignores, which then also leads a little bit to the criticism of the circular economy, because why do we need to build something complementary if the circular economy is already perfect? Good. We're going to meet again in 10 minutes for now for the Q&A. Q&A for lecture 4 that you watched at home, lecture 5 for today, potential exercise questions or any types of feedback, criticism, and whatever comes to your mind. Thank you very much, and see you for the next lecture or the next video. Bye-bye.